Hi and welcome back. So at the end of the last video, and actually towards the beginning also, we were talking about scientific notation, and I told you that one of the things that scientific notation is really good for is for representing significant figures. And I haven't told you yet what significant figures are, so I figured now's a great time. I'll use this video to tell you about significant figures. So pretty much what significant figures, and this video might be more of a video about the intuition behind why significant figures are used more than the actual rules of dealing with significant figures. We'll definitely get into the rules of dealing with significant figures in a future video. But for dealing with significant figures, one of the important things to have is a little bit of an intuition behind why they're used. And pretty much the reason that they are used is they tell us how much information we know about a measurement. Sorry if my handwriting it's kind of sloppy at the end, but that's pretty much what significant figures do. They tell us how much information we know about a given measurement, or how good a measurement is. So anyway, and the way that they do that significant figures does this, it's not by maybe I don't know if you've seen this before, where we say if you say have a measurement that says, well, we have 1.2 grams of some substance, and that measurement has got a 0.7% error. So pretty much, maybe you've seen this in the past, and it's definitely useful to be able to calculate the percent error in your calculations. And significant figures doesn't exactly do the same job that calculating the percent error in a calculation does. But significant figures, it sort of does a similar job. It sort of does a similar job in letting us know how good our measurement is, or how much information we know about a given measurement. So in order to do this, let me actually give you a little bit of an example. Let's say, and it's an example that's going to be very similar if you're in a chemistry class, and specifically a chem class where you have to take labs. Very, very similar example to what you'll be doing in those labs. So let's say I go to a grocery store, and they have a scale at this grocery store, and let's say I go and I buy, let's say, what's something easy to draw? Let's say I buy an apple. So there, that's my attempt at drawing an apple. So I buy an apple, and this apple, let's shade it in maybe. There we go. So this apple gets placed on their scale at the supermarket, and the scale's got a digital readout. And let's say that they say that this apple weighs, let's say, 0.42 pounds. So I think that's about how much an apple weighs. It's like a little bit less than half a pound. Maybe it's a medium-sized apple. I think that's about how much they weigh. But not that it really matters for this video. But anyway, so they say that our apple weighs 0.42 pounds, and that's how much they charge us for at the grocery store. And let's say I was really obsessive, and I really wanted to know a better weight of this apple. I say, well, you only gave me 2 digits here. That means, let's say if I have 2 digits, that are going to be changing, how many values can I represent with these two digits? So if each value could be or if each digit could be anywhere from 0 up to a 9, I can represent 100 different values here, right? So there are only 100 different possibilities of how much this apple could weigh in this this example. And let's say I just really wanted to know more information about how much this apple exactly weighed. So I went to, let's say I went to a lab. Let's say I went to a lab and they had this really nice, draw it better. Let's say they had this really nice brand new orange scale that they just bought and they just spent like, I don't know, $10,000 on or something. And I wanted to figure out how much my apple weighed at this really nice lab. So I go ahead and I put the apple on the scale. And again, the scale's got a digital readout. And it tells me that this apple weighed 0.417612. Actually, no, that's too much. Probably, let's say it's a 0.41796 pounds. So now, this measurement, it tells me much more information. And again, it's still an estimate. We don't know exactly how much this apple weighs, right? There are infinite possibility. Well, I guess there's not infinite possibilities for how much the apple exactly weighs, but there's close to an infinite infinite number of possibilities for how much this apple could exactly weigh. And this is still, it's just an estimation though, right? But you can tell that it's a better estimation than what we got at the supermarket. The supermarket, we only got 2, and we'll figure out that this is 2. We only got 2 significant figures out of the scale there, out of the scale at the supermarket. From this really nice $10,000 scale at our laboratory, we got 1, 2, 3, 4, 5 significant figures. So we got 5 different significant figures that, could be any digit from a 0 up to a 9 that are telling us information about how much this apple weighs. And this might be, hopefully, this might be getting a little bit advanced for a chemistry class, but it's good to think about how many different values could I represent with 5 different digits. Well, all from all of them being 0 to all of them being 9, I could represent 100,000 different values here, right? So that's much more than how many values I could represent with only 2 sig figs. So again, this is 5 sig figs. So with 2 sig figs, I could only represent 100 different values. With 5 sig figs, there are 100,000 different possibilities for there are 100,000 different possibilities of estimations of how much my apple actually weighs. So anyway, the important thing to come away is that because we had more digits in our readout, that this measurement, this 41796 measurement, is a better estimation of how much the apple actually weighs than this 0.42 estimation is. That this information, this measurement that we got with our orange scale tells us more information than this measurement did that we got with our blue scale. And hopefully you can see too that and they're totally different scales, and this wouldn't necessarily happen in real life. But we can see that this scale, maybe in the computer inside this scale we actually got one more digit of significance. But the only reason that was there and not reported was to figure out how we want to round this figure. So we can see that we're actually seeing that figure in our orange scale, and we got 0.417, and in our blue scale, that 1, because our digit just to the right of the 1 was 5 or larger, that our digit that's in our hundreds place on our blue scale got rounded up. So, and anyway, that might be there. I'll definitely do more on that in the future. For this video, I just want you to get the intuition that this measurement, because we have 5 significant figures in this measurement, gives us more information than this measurement does, where we only had 2 significant figures. So in the next bunch of videos, I'll just give you more information on how to count significant figures and all the rules associated with significant figures when we multiply, divide, add, and subtract different numbers. So anyway, hopefully this didn't confuse you. Again, if anything confuses you, please leave comments, and I'll definitely try to update the offerings on the channel. So anyway, thanks so much, and I'll see you in a future video.